Good morning, good afternoon, and good evening, and welcome to today's webinar hosted by NXP with our partners at Variscite. Today, we'll be discussing how to design a scalable embedded product supporting different NXP i.MX applications processor families. And as an added benefit of joining this webinar, you will receive a discount coupon to use on any Variscite board of your choice procured on their web store. Be on the lookout for an email with more details. For today's webinar, the panelists include Robert Thompson, MPU Ecosystem Manager at NXP, Ofer Austerlitz, Vice President of Business Development and Sales at Variscite, Aviad Haddad, R&D Hardware Expert at Variscite, Pierluigi Passaro, R&D Software Expert at Variscite. During the webinar, you can type in your questions in the question box found in the GoToWebinar control panel on the right-hand side. We will address as many questions as possible during the live Q&A at the end of the webinar. Should you want to download the presentation and follow along separately, please find the slides available in the handout section of the GoToWebinar toolbar. With that said, I'll hand it off to Ofer Austerlitz from Variscite.
Hi. In this webinar, as mentioned by Megan, we will discuss about how to design a scalable solution for your embedded design. In that regard, we're going to start with a short overview about the system on module concept for such a scalable design. Then Robert will talk a bit more about how this is supported by the i.MX portfolio, the processors that are below the system on module. Then we'll go more into the pin-to-pin concept of the system on modules and the hardware and software concepts that are related to a scalable design. The ones that are not familiar with the system on module concept, practically this is the first base of how to design a scalable solution. It is based on a two-board design that has a carrier board that is practically taking the system on module that is sitting on that as a kind of a mother and daughter card concept and adjust the system on module to your specific design, this specific end product with all the interfaces that are related to your own end product and naturally also the form factor, the size, and if you have a specific thermal or temperature grade that you want to practically adjust your end product. The system on module that is sitting on that includes the i.MX processor that is scalable by its own, but the system on module provides additional scalability with numerous options on the memory, the storage, the optional Wi-Fi, for example, that can be sometimes single or dual band, and more scalability options that are supported by the system on module itself. And this is practically something that is provided by Variscite, and we are providing you the option to select the scalability and the configuration for your own specific product. In that regard, we have our own production lines, and so you can have thousands of different configurations for each and every system on module. So this is the base of the concept, each system on module, as I mentioned before, and this is one example of the Varsom MX8M Mini that is based on one of the latest i.MX 8M Mini processors that are coming from NXP, is including the processor itself, naturally, the memories, as I mentioned before, that can be ranging from, I don't know, sometimes 512 up to 4 GB of memory size. The MMC is fully scalable, and then the others that you can see here that can be either embedded in your system on module or not, like the Wi-Fi or the CAN bridge, audio codec, Ethernet PHY, and such. Naturally, the system on module concept giving you a fast time to market, you can take that. It reduces the cost of your R&D. We are going to discuss in further details about the scalability and upgradability that you can actually move from one processor to the other by the pin-to-pin concept. So Robert will soon discuss the scalability within the i.MX processors. But even if the i.MX processor are not pin-to-pin on the processor itself, we can make the system on module pin-to-pin, which enables the customer to take the system on module based sometimes on i.MX 6, for example, and then scale it up to i.MX 8, if it's mini, nano, 8X, 8 quad max, and such. So you have here the full I would say, concept of the system on module. I'm going to hand it off now to Robert to talk a bit more about the i.MX ecosystem and everything that is related to that.
Great. Thanks, Ofer, for the introduction. So as Ofer mentioned, scalability is key to the i.MX portfolio. The initial i.MX portfolio of products scaled from a single core to a quad core, utilizing the same set of IP, so was able to maintain the pin-to-pin compatibility and software compatibility, which is so key to our success, but also the ability to scale across a portfolio. This scalability introduced the ability for designers and key partners such as Variscite to up or downscale performance during development without having to reboot the design process from scratch. As the demand for application processors has grown, new variants of the i.MX 6 portfolio were added. However, the overall software compatibility, the same Linux Android BSPs, still run across the entire portfolio, so enabling our customers to develop a portfolio of products that are scalable. The i.MX 6 portfolio has been successfully designed into devices as varied as high-end auto infotainment systems to single-function temperature tracking instruments. With this success, we saw the opportunity to bring greater performance and features and improved power with the i.MX 8 family. The i.MX 8 portfolio is split into three main families. The i.MX 8 featuring the 8 Quad Max that takes the next step in graphics performance with a 6x improvement from the 6 Quad Plus, enabling up to 4 high-definition displays. The 8X aimed at the industrial market with the right balance of performance, power, and safety features, and the 8M that is optimized for video, high-definition audio, and voice, which are now all becoming key features across many of the industrial and the IoT markets, which are key for us, but also for Variscite. And if we look at the i.MX 8 family in more detail, if you can go to the next slide, Ofer. Thank you. So if we look at the i.MX 8 series, the three families are aimed to fully cover the rapid expanding use cases and vertical markets that ARM-based processors are now addressing with the help of key partners such as Variscite. This wide array of use cases from advanced automobile clusters to streaming high-definition video and audio has resulted in the need for vertical specific IP to support specific use models. With this, pin-to-pin compatibility is maintained within the families, so scalable solutions can be built as shown in the next slide. So if we can go to the next slide, over. So as you can see on this slide, within the 8 and the 8X families, pin-to-pin compatibility has enabled companies like Variscite to efficiently build a scalable portfolio of products within the family. However, between the 8 and the 8X, because we have a 70% reuse of the hardware IP, this has enabled software reutilization with the same Linux and Android BSP still running across both of these families, and also the 8M family. The 8M family uses the same core CPU technology, the ARM A53s, but adopted different process nodes to deliver key productivity improvements. So let's take a closer look at the 8M series with the next slide. So if you look at the 8M series, which was the first was the first part of the i.MX 8 family to launch, the 8M series consists of 3 families that are launched and one, the 8M Plus, that will launch at the end of 2020. The 8M Quad launched in 2017 and was the first i.MX part specifically aimed at the multimedia market, supporting 4K HDR, HD audio, which maintain the overall family approach because we have pin-to-pin compatibility across the different variants of that family. The 8M Mini and Nano, launched in 2018 and 2019 respectively, transitioned to the 14 nanometer FinFET process node, so significantly reducing the power profile while adding key features such as video encode and support for digital microphones. The 8M Plus maintains the same 14 nanometer FinFET process nodes, but takes the next step in that processor development by adding a dedicated neural network accelerator, integrates a DSP and an ISP to enable a range of machine learning and artificial intelligence usage models with low latency and power. The 14 nanometer FinFET choice for the Mini and the Nano enables pin-to-pin compatibility, but also faster operating speeds for the core A50 for the A53 cores at lower power consumption. This power efficiency and performance is one of the key drivers in the wide adoption of this family across many different vertical markets, but that both are key for both NXP and Variscite. So if we go to the next slide, we can see these wide variety of markets that the i.MX 8M family is aimed at. Since its launch, the 8M has been rapidly taken to production in a range of markets, from consumer to IoT, including smart home, and industrial markets, from automation to healthcare. However, to enable the vast majority of our customers to get to market, we need key partners such as Variscite that takes the SoCs that I've briefly taken you through and create boards and system on modules that enable our customers to fully utilize the features of the i.MX in form factors and products that shorten your time to market and so increase your product success and competitiveness. And with that, I'll hand it back to Ofer, who will take you through the scalable families of products that Variscite has built around the i.MX 8 family. Thank you, Ofer.
Yeah, thank you, Robert. As I mentioned before, on top of the fact that there is scalability within the i.MX 8 processors themselves, like in between the Nano and the Mini, or the different flavors of the Mini that can be single, dual, or quad-core, Variscite practically designed two families that are pin-to-pin to each other. The Varsome, as we call it, which is an edge connector of 200 pins, and below that, the Dart pin-to-pin family that is based on 3 board-to-board connectors that are sitting at the back. The advantage of the Dart is mainly the size, which is optimized for portable or the products that are limited on size and form factor. It is also a bit more, I would say, robust for shock and kind of vibrations due to the fact that there are 3 connectors that designed in the back. You can see here the scalability of the Varsome, for example. It starts from the i.MX 6 UL and ULL at the top right, scaling up to the, let's say, regular i.MX 6, single, dual light, dual, and quad. Then going up to the i.MX 8M family, starting from the Nano to the Mini to the 8X, 8 Quad Max, and the coming 8M Plus that will be introduced in the coming month. We are early partners of NXP on all of them, and we practically launch them together with NXP launch of the processor. Same goes for the Dart pin-to-pin that you have here below, which practically gives the customers the ability to design a carrier board that can be scaled up from the different processors that you have today, but you can also count on the fact that if there will be an i.MX 9 or when there will be an i.MX 9, 10, we will keep the pin-to-pin scalability that you're practically using today to be used and scale up to the future processors coming from NXP. And this is the concept of the pin-to-pin compatibility. And now we will go a bit deeper into the hardware details of the design presented by my colleague Avihad here.
Thank you, Ofer. So today I'm going to talk to you about how to design a scalable embedded product using the pin-to-pin families Variscite has to offer, explain the pin-to-pin compatibility concept and pin mixing. We'll have a look at Variscite's compatibility spreadsheet and the Symphony board schematics, which can be used as a reference, and talk about some guidelines for your carrier board design. So there are 2 pin-to-pin families. The first is the Dart MX 8M family, and the other is the Varsome pin-to-pin family. We will be focusing on the Varsome pin-to-pin family. The family members are starting from Variscite's mature Varsum MX6 and its subsidiary, the Varsum Solo Dual SOMs, going through the Varsum 6 UL based on the i.MX 6 UL, and up to the latest family of processors, the i.MX 8 and the i.MX 8M families. All of these SOMs connect using a SODIMM 200 pin connector. Benefit of this family is that it's very scalable, highly configurable, and there are various choices of interfaces. These SOMs export almost every interface of these CPUs. There are major interfaces compatible between all of them, and they all contain interface controllers such as the Wi-Fi Bluetooth module, the audio, the Ethernet controller, and also a resistive touch controller. They all connect to a single carrier board, which is a Symphony board that demonstrates all the major interfaces this family has to offer. So before getting into the details, let's watch a short video that will give us a quick overview of the Symphony board.
Symphony board is the Variscite open source solution for Varsum pin-to-pin compatible modules. Schematics and PCB layout are provided in a Lego ORCAD format. It's also possible to have them in Artium format, got by semi-automatic conversion. Specifically designed for customer integration facilities, it may be considered and used as a reference point not only for time saving during schematic and PCB design activities, but also and mainly as documents reporting notes and directives for reliable products. Dedicated pages to every supported SOM have been added in order to quickly drive customers into their specific needs. Tips and tricks such as electronic switches able to redirect pins according to the SOM in use and totally supported by our BSPs. Designed not only as a reference point, as this project integrates every single detail like a full PCB constraint list, exactly like a final customer product. And last, but certainly very important customer advantage, Variscite offers free of charge schematic and layout review to the customer final project.
So based on our experience with the needs of the embedded market, we selected a compatible pinout that provides the most commonly used interfaces and ensures that for all SOMs of the family, these interfaces will be exported in the same pins. There are fully compatible interfaces, partial compatible interfaces, and some that are unique to specific SOMs. So if you take a look at the Varsum MX8
Sorry, but screen is not visible.
Then in blue, we will see the compatible interfaces, and in gray, we will see the partial or unique interfaces. So when one designs a pin-to-pin compatible product, they should verify that the interface selection falls into the standard that we have set in this pin-to-pin compatibility. So what makes pin-to-pin compatibility possible is pin muxing. So if we take a look at the Varsum MX8M mini datasheet, for instance, you can see the main pinout table that corresponds between the CPU ball and the pinout of the SOM. It also states the assembly option in which this ball is exported. There's also the main pinmux table showing all the alternate functions for each pin, and a breakdown according to interfaces which show from what pin and specific function can be exported. In order to simplify this, we have the compatibility spreadsheet, which has a separate tab for each SOM showing all the pinmux option of the SOM. In addition, there's a compatibility pin map tab, which in one glance you can see all the pinmux options of a specific pin. You can also type in the number of the SOM pin and see all the possible pinbox options for every SOM. You can also select from a drop-down menu an interface, and it will show you the occurrences of that interface throughout all of the SOMs. So let's look a little bit about the Symphony board schematics. The Symphony board schematics contains a SOM symbol, which has the pinout for all of the Symphony board. The compatibility list shows all the alternate functions available for each pin, and the off-page connectors show compatibility according to the name. So if the pound symbol is appearing in the off-page connector's name, it is a compatible function. There are dedicated pages for each SOM, so you can cross-probe between the SOM symbol and the specific SOM connector you're using by setting the implementation tab to the correct SOM you're using. Here we see an example of the interfaces which are compatible and partially compatible. For instance, LVDS has the pound symbol in it, so it is compatible across all the SOMs of the family, while HDMI is partially compatible between a few SOMs. So a few guidelines when coming to design your board. So since we made an effort and tried to maximize the number of compatible interfaces across this family, I suggest you start by adopting the EVK pinbox selection as a baseline and add interfaces which are missing according to available pins. Now, if you need some interfaces which are not exported, you should verify that these pins are always available and not used by the SOM for other function, and are not dependent on certain SOM assemblies. You can find the exact details in the datasheet or in the spreadsheet. The most areas which should be handled carefully are the power, reset, and boot areas, since they are very error prone. In terms of boot, you should verify that the boot pins are not driven externally. Reset is handled on our carrier board. You should have a look at our design. In terms of power, you should ensure sufficient supply to the module. You can find the typical figures in our datasheet and also measure on our carrier board according to your application. Pay attention to the carrier board peripherals supply, and basically try and follow these areas as much as possible from the EVK, since they were validated on all of the SOMs of the family. So that will save you a lot of time. In terms of placement, the layout and schematics are provided on our FTP, the design files. So you can use them for symbol use, placement, and footprints. It can save you a lot of time. When you come to place the SOM and its holes on your carrier board, you can either import the layout to your layout file, or use the DXF provided on our website and import them to your layout. In terms of stack up, for a typical design that uses most of the interfaces, I suggest using 6-layer stack up. You can work with your PCB manufacturer to provide a stack up that will give you all the impedances with the practical face width spacing ratio, and ensure reference planes for all the high-speed signals. So these are a few general guidelines for high-speed routing. Basically, you should try and route the high-speed signals first and together as a bus. Also, length match them and minimize the crosstalk between them and other signals. In terms of power, you should follow the placement and routing guidelines of power supplies to reduce and avoid DMC issues. And again, all of this is implemented on our evaluation kit. You can download the design source files from our FTP and the some 2D and 3D files, and use it in your design. That will save you a lot of time and risk, and bring you early to production.
Thank you, Aviad. We are moving now to the software aspects. Pierre, you are on.
Yep. Hi, everybody. I'm Pierre from the R&D software expert. We will go through the software scalability aspects, starting from the definition. We will go through the Android approach. We will talk about the hardware abstraction layer provided by the Linux kernel. We'll talk about wrapper libraries and some hints about the application design. Let's start with the definitions. From a general perspective, usually when we call about scalability, usually you have a system scalability. That is the capability of the system to adapt to the specific problem that you need to solve. From a software aspect, usually you mean the capability of the software to correctly manage a different workload. In the general perspective, in terms of users, but in our perspective, we think to the capability to run a different application on the same board using different SOM. So let's see how Android approach this question. All of us, you may have experiencing using Android phone. You can just download your application without taking care of which model you have. How did it can happen? Because Android provide what is called an SDK, software developer kit, that allow you to write an application that can run on several devices. This is because Android is structured with some application framework, some library, and as a kind of adaptation layer between the Linux kernel that provide the access to the hardware and the real user space. This is called the hardware abstraction layer. Let's see about the limitation of the hardware abstraction layer in the next slide. So basically, Android SDK does not allow you to access the buses. As you don't have direct access to GPIO, SQLC bus, SPI, and whatever. But if you look at the SDK APIs, you can see that you can access the functionalities. So you can manage the LEDs and the keys. You can manage the audio, the sensor, the Bluetooth, and the cameras. They are connected to the bus, but the SDK abstracts the access on these buses, providing you the functionality to manage these aspects. How this can be possible? Let's start understanding how this starts from the hardware abstraction layer in the Linux kernel in the next slide. So basically, what is happening is that the kernel provides availability for several drivers exposing similar interfaces. So you can mount one codec or another. You can mount one power supply rather than another, one touchscreen rather than another. The point is that from a user perspective, you just receive the audio interface, the power supply management, and the touchscreen interface. You don't have to care and deal with the specific hardware aspects. Just as example, here we report a backlight in the device 3. This backlight will be exposed in the virtual file system as a file that you will be allowed to edit, changing the value that represent the actual backlight. You don't have to deal about how this is happening. So why this is possible? Because on several SOMs, we exposed on the same pins the same functionalities. Just for example, this is possible because of the NXP pin muxing capability. So each pin can expose different function. Each pad can provide different function. And for example, if you have a look to our Symfony board, the connector J18 at pins 3 and 5 always expose a UART for all of the SOM that you can connect. Let's go on and see how the device tree can help. let me report a couple of examples that are very useful in the real life, because we are talking about GPIO keys and GPIO LEDs. So basically, generally speaking, you can access a GPIO and control it in output, in input, assign a value from the virtual file system that is exposed by the kernel. But this is not useful whenever you need to port your application to a different hardware. This kind of approach allows you to assign labels to a key that will be used as like a keyboard key, or to a LED that will be used just to as an output, so that you can power on, power off, let it blink. Here we are reporting just the device tree implementation, but from a user perspective, they will be simply accessible through a label that will be hide in such a way the problem to manage directly the input or the output, or the customize the hardware itself. Going on, one of the aspects that can be avoided in order to reduce the problems is the direct access to the buses. For example, one of the useful example is the RTC. Doesn't matter which RTC you're going to use, as long as you expose it as an RTC, no matter if you use an I2C bus or another, or it's an SPI bus, whatever you want. But from a Linux perspective, this will be exposed simply like a /dev/RTC0 that will help the application to have a single access point to get the real-time clock. Okay, but there are also some limitations. I mean, till now we are referred to generally to the GPIO and to the UART, but there are system on chip that provide a second Ethernet access, GPU, video processing unit, but not all of them may expose the same capability. But not only, different devices may have different naming convention. For example, if you take the Symphony board, I reported that on the same pins there is always a UART available, but for different some may have different name. For the M-Mini and the M-Nano, this UART is called TTY-MX2. For the 8X is referred as LP1, and for the MX8 as LP2. So how can we work around this? Basically, trying to, first of all, probing the hardware capability, and providing library that can wrap the specific capability that are provided from a system on chip or a system on module. This may simplify the application, because the application will have a single entry point from the library, and the library will somehow probe and manage the differences. Not only, you can also prepare some plan to use some configuration files, for example, for the names, like the UART names, that will simplify the application. You will just have to take care that the configuration file will specify which is the UART that you're going to access. Okay, and finally, we go to the application design. We aim to have no hardware dependency at all, and you are supposed to develop your application on a specific SOM, but running it almost everywhere, even on a Linux PC. So we're not just talking of hardware or software scalability, but we are aiming to provide you a simultaneous hardware software scalability. So you can use one board, one application, and different SOMs. This is the approach that we suggest to the customer to let the application much more portable. Beyond this, in the last months, years actually, we observed an increased use of Docker containers. Docker containers have been developed to virtualize the devices and the resources, like the processes, from a specific host to a generic container. This usually allows the developer to have a single interface and to deploy their own application on different hardware, because all of the differences may be somehow managed through the virtualization of these devices or these resources, exporting them from the host to the container itself. This closes basically the review about the scalability. Here you can find our reference for the mail, the website, the wiki, and the customer portal. And
thank you, Pierre. I think we're on to questions. Yes, okay, so let's start with a few hardware questions that have come in for Aviad. So the first one that has come in is, how about the reliability of the SOM connection to the board? Can it withstand shock and vibration?
Yeah, so for the Dart family, as Ofer mentioned, it is board-to-board connectors, actually the F40 series from Hi-Rose. They are very durable and industrial grade as well. For the VAR-SOM family, the SODIMM connector is very durable as well. It complies with the SODIMM standard used widely in the embedded market. We also have mechanical preparation of holes on our SOM and the carrier board for adding studs if you need additional fastening. Also, we have in the schematics the part numbers of these studs, so you can refer to that.
Very good. Okay, one more question for you, Aviad. How do you deal with the fact that there are different interfaces on the same pins for different SOMs, such as HDMI, DisplayPort, or parallel camera, as you have shown us?
So we provide extension boards which connect to the PCB edge connector and can utilize the specific interface of each SOM from the same connector. We have an extension board for the HDMI, the DisplayPort, parallel camera, which can be supplied with the EBK. We also have extension boards for different camera models, such as the OV5640, the Bustler Beacon from EP, and we'll have more in the future to support other sensors. The schematics and the layout of these extension boards are also available for customers, so they can use it in their design.
Very good, thank you. We have a software question for Pierre. How can GPIO keys be used in Android or Yocto?
Well, basically GPIO keys provide the keyboard events. So both Yocto and Android provide some dedicated utility, open source utility in C in native code that can show you how to access the native interfaces from Linux. Not only Android SDK provide dedicated APIs to access the keyboard events, so you can just wait for an event in not polling mode. This is useful when you don't want to use the CPU too much. That's it.
Okay, and then similarly, how can GPIO LEDs be used in Android and Yocto?
GPIO LEDs basically expose a dedicated folder in the virtual file system, usually under sys class LEDs, followed by the name of the LED, that allows you to set the brightness, decide the blinking policy, or whatever. This can be used either natively, just referring to the name of the LED, or for example, in Android, there is a specific HAL managing the LEDs that can be customized upon following the customer requirement to provide specific behavior to be implemented and used.
Thank you, Pierre. And then one more for you. How can Docker help me to develop an application?
Well, basically, Docker is able to remap devices and resources from a container to, from a host to a container. So basically, if you want to expose a specific I2C bus, let's see I2C2, you can always expose in the containers as I2C 100. This will allow the container to have always the specific reference. And whenever you will move your application to a different container, you just need to use the same policy. When the container starts, the starter of the container need to share maybe a different I2C bus, but with the same alias name. That's it. This is the base concept of Docker. You virtualize the devices, assign them a different name, but that can be always the same on the container side.
All right, thank you, Pierre. So now we have a question for Ofer. Which Variscite SOM has the lowest power requirement? Not sure if you know that off the top of your head or not.
I sure do. In general, the ones that are based on the 40 nanometer that was actually discussed before by Robert, from the i.MX family, the NANO is currently very cost optimized, very power efficient as well, especially if you are using that in a single core kind of configuration. The ones that are inside the Dart family has another advantage because the Dart family is actually using low power DDR. So in that regard, it also consumes less than the DDR4 that is inside the VAR-SOM in general. And it really depends on the general, I would say, end customer requirements, which interfaces he wants to use it, which performance, multimedia features he has inside his product. In that regards, there are other solutions that might come even from previous i.MX 6 ULL in a kind of single core, but I would say a lot of interfaces that are integrated inside. It is very power efficient as well. Again, if you don't need the performance of dual or quad core or more multimedia features inside. So the entry level, I would say, will be the 6 ULL for very efficient power consumption. Then above that, you will go with the Nano or the Mini with the 40 nanometer design that is integrated within the silicon node itself.
Very good. Thanks, Ofer. Another one for you. What is the usual development time for a carrier card?
Well, it's a very good question. Really depends on, I would say, the capability of the engineers on the other side. We have seen customers designing their own carrier board in a matter of weeks. If there are not too fancy features that are added on top of the reference design of Variscite, I would say that a typical carrier design can be really a matter of weeks, especially if they are using the portal of Variscite and they can submit their tickets. And as mentioned before, even the schematics and layout reviews, we are doing that, and then quickly the customer can go to produce his own custom board. Usually first time right, again, if it was going through the design review that came from Variscite. So it really up to the customer. So if he is running fast enough and he is assigning the resources to design that, I would say in a matter of weeks he can go to production of his own carrier board.
Very good. Here's one. I've seen a few questions come in with regard to e-ink. So let's just push this one forward. Is there any VAR-SOM with populated EPD for e-ink display connection?
We are not providing the EPD or the ink as part of the reference design because naturally we cannot support numerous display options or camera options. So we are providing with a couple of display options that we have in-house. What we do have system and modules that can support EPD. We have customers that succeeded to do that, for example, with the i.MX 7, the 6UL even, and naturally there are some specific processor derivatives of those i.MX processors coming from NXP that should be ordered in advance because this is not the usual part number that we are integrating into the kit. So there are actually specific flavors also coming from NXP in order to support the EPD. Once we know in advance that the customer is targeting that, then we can tailor the configuration and put this specific processor flavor inside. And then KEPD can be exported to the carrier board and the customer can use that.
All right, thank you, Ofer. Now I have a question probably for Aviad. How many of the CAN ports are brought out on the i.MX 8X part? Is it possible to use all three?
It is possible to use all three. It all depends on the PinMux selection you're using. On our Symphony board, there's one compatible CAN interface. So it really depends if you need all three, then you can define the PinMux to use all three, but then you have to see what is what you have to give up on in these pins.
Okay, thank you for that. Let's see, there's a lot of questions here, so thank you, everybody. Let's go with, is it possible to use a C process to access the hardware as in General Linux? So maybe that's Pierre.
Here I am. Always, actually. Basically, what's going on is that you can always access the full Linux capability from the user space. Let's say that this is much more easy by design if you use Yocto or generically a Linux operating system. From the Android perspective, this is a bit more complicated just because of the security policies that have been introduced in the last Android versions. But it's just a matter of security. You can do the same. You just need to allow specific processes to do specific things. But you have the full control of the machine, actually, in any case.
Okay, thank you. And then another question, do you provide a Linux kernel with low latency optimizations? We want to do low latency audio with multi-thread audio processing.
This question is very interesting because we deal with it several times in our experiences. Let's say that the latest Linux versions actually include some patches that have been provided some years ago from MontaVista that have introduced a very optimized management of the latency. I'm saying this because Linux is not and will never be a real-time operating system, but in the last year we observed a very nice increment of the performances in terms of latency to the internet. So in our experiences, we had the customer that applied the real-time patches to reduce this latency, but we have several audio providers that just use the kernel as is, and they are not experiencing a specific problem. By the way, this is a question that we often receive. And the first answer that as developer, I'm suggested by my mind is try and let me know how far you are from your target.
Okay, thank you for that. Now, a question, Pierre, for you as well. What graphics environment do you recommend that takes full GPU advantage?
If we are talking about the i.MX 8M and i.MX 8 family, all of them are based on Wayland. I mean, the acceleration library that are provided by Vivante do support the Wayland environment. So actually, the only requirement that you have is to use Wayland. On top of Wayland, you can simply decide what to use. You can use Qt5, you can use GTK, whatever is fine. I don't want to deal about licenses, but it's mainly a problem of licenses if you want or not pay specific licenses. But nowadays, it's just a matter of graphic libraries that support Wayland. Once you have a graphic library that supports Wayland, you can just say that your acceleration will be managed correctly.
Okay, and another one for you, Pierre. Do you have examples of Docker on i.MX 8 SOM?
We have a dedicated section in our wiki explaining how to enable Docker, how to run a Docker example, and we provide the specific Docker example, for example, to run a server application rather than we are increasing this section with a new graphical examples, and it's mainly on the wiki in a dedicated link for each SOM that support Docker.
Okay. Now, concerning Wi-Fi and Bluetooth, do I need to pass certification for my carrier board?
It's a very good question. We are practically using a certified Wi-Fi and Bluetooth combo module on all the i.MX 8 family, and also the previous modules that were introduced in the last couple of years, like the 6ULL and also the i.MX 7. We are using layered Sterling LWB for the single band or LWB5 for the dual band. Both of them are certified for FCC, CE, and even some of the Asian countries. We copied the exact design done by Layered. So the system on model itself is practically certified as well by the modular certification. The customer has a UFL connector that is on top of the system on model itself. We can practically plug in the antenna directly to the system on module. If he wants a cheap antenna, then he needs to put that on the carrier board on some other PCB. But if he's using a dipole or a wire antenna, we can practically connect it directly to the system on module. So the carrier board is practically out of the Wi-Fi RF path at all. And the customer practically can go to certification very easily using the modular certification process, again, leveraging the fact that the Wi-Fi was already certified before. Naturally, there are some aspects that should be taken care, like using an antenna gain that was not higher than the one done by Layered for their own certification, because if you're taking higher gain, then you go out of this certification that was done before. But if again you're careful with your antenna selection, then it is very easily taken to certification, saving you a lot of time and also money.
And Ofer, while we have your attention, it's in a similar vein. Can you speak a bit about sourcing, lead times, and availability of variations of SOMs for low-scale prototyping and full production?
Absolutely. So the kits, as well as stock items that we keep in-house practically on the shelf to support customers that are starting with the design or just moving into prototyping in low quantities, then the lead time is just a few days. You order, you can also see them all on the web store. You can order directly from the web store, pay with PayPal, and within 2 to 3 days they are shipped out to the customer. If you need your own specific configuration, which has a relatively low MOQ of 100 units, then naturally we need to produce this specific configuration to the customer demand. This is usually done on later stage when the customer is moving to production, or let's say prototyping, but not the first prototype. Usually this is, I would say, the pre-production batch. Then the lead time is something like 14 weeks. Usually we can expedite that, but this is, let's say, the standard lead time that we state in advance. 99% of the cases we can even ship sooner. Again, this is for the specific configuration. For stock items and kits, this is just a matter of days.
Thank you. And I guess it leads nicely into the question, does Variscite offer development services for carrier boards, schematics, layout, testing, as an example?
Yeah, sure. Each case is actually on its own, since we have like 5,000 different customers. Naturally, we cannot design all the different carrier boards for everybody, so we are very selective on that. We test each case by its own. We are more flexible on the software. If a customer needs a specific software design, driver adjustment, then we can do that internally. At the same time, we have a very strong ecosystem of partners that have a lot of experience designing the full system around the system and model of Variscite, both on the hardware, software, but even beyond that, they can actually do the case itself. They can even certify the entire prototype for the customer and bring him the full system after designing the hardware, software, application layers, and everything that is related to the prototype. So it's really a kind of case by case that we need to define and discuss in details. All options are open for that.
Thank you. We are nearing the end of the webinar. I'm going to take a few more questions that I see here on the software side, and then we'll wrap it up. But please, if we did not get to your question, there are many, and we apologize for that, but we will make sure to follow up with you directly on those questions. All right, so Pierre, a few for you, and then we'll wrap it up. Are all software libraries and build tools provided by Variscite to build a Linux image from scratch license, free for commercial use?
Let's say that whatever we provide is public. Actually, is in our GitHub repository. We have no hidden parts. When we provide the instruction, the customer will go through the Yocto standard process and will download packages. Each package has its own user license, and we actually do not we not deal with the problem of the license because our system is completely open. I mean, some licenses ask the customer to propose all of the changes that he applied. Some other customer required the customer to allow a full access to the system in order to allow a change of the libraries. We provide system modules and we provide boards. Our systems are open, but it's not always true that a product is an open system. So you have to deal with the license itself and understand what the license requires you to apply and take care of it. From our perspective, everything is open, but we don't have to hide anything. That's it.
Okay, thank you. And another question, do you have any recommendations on how to reduce the Yocto Linux startup time? How low timings could we achieve?
Let's say that the initial tuning it's not that critical. I mean, the first point is always to remove all of the prints that you have on your console because they are time consuming. This will allow usually to reduce of about 5 seconds. You have some timeout in the U-boot that you can remove. Then you need to start the real hard optimization. You need to remove whatever is not needed. You need to move whatever is required as possible as a module. And you need to optimize your services in order to just start what you need. We have example of customers that are below, highly below 10 seconds, but it depends on how much you want, how much time you want to invest in order to achieve a better time. You will never reach the real time. I mean, your application will never be up and running in 1 second, but you can still have something like 5-6 seconds. It depends on the requirement that you have on your final target.
All right, very good. And we'll call it, this will be the last question for today. I know most of NXP BSP version is Yocto. Can we run Apache PHP MySQL server on the Yocto MPU?
Oh yeah, absolutely. Basically, what you need to do is add the right packages. first of all, you need to identify the packages. Just remind that we rely on the NXP based BSP. On top of it, we add our customization, but generally speaking, we provide the Yocto standard BSP based on POCI. There are some basic layer added, let's say METOP and embedded or something like this, but you may require additional packages. First of all, you need to understand which are the packages that you need, and also the sub-packages, because Yocto split the builds of a specific package like PHP, Apache, or MySQL in different sub-package, and you need to check when the build is completed which are these sub-packages and what they contain in order to understand what you really need to add. It's a delicate process, but it's very efficient.
All right, very good. Thank you so much. So at this time, I want to thank all of the presenters for their time and their information. I want to thank all of the attendees for participating and giving us your attention today. I wish everybody the best. Have a nice day.